And I'll reshare. All right, so yes, function g is showing us the signed area below the x-axis from x equals 2 to beyond. So let's do this. Let's write a function for g of x here. So how can I define a function that tells me basically any signed area starting accumulation at 2, at x equals 2?
Would it start off with the integral from 2 to x?
Well, I can't do it like that. Yeah, so it would be the integral starting from 2 to x. Where are you, integrals? Well, so lower limit 2, upper limit x, good. All right, somebody else continue this for me.
Do you put the rate of change of g next?
Okay. What is the rate of change of g in this case?
The y value?
The y value. And what function is giving us our y values?
F of n.
F, okay. So tell me what you think of this. Are we okay with that? That function to give us the signed area below the x-axis.
Doesn't f of x and d of x have to have a different variable?
Absolutely. So why do we need to do that? Why can't I just call this one x as well?
Because we assigned x as a variable as the upper limit. So it can't be the upper limit and a variable. It's serving as a parameter right now.
Yeah, that's perfect. So yeah, the way we've defined this function, once I pick a value of x, it is not a variable. It's a parameter. T is the thing that I vary from 2 up to x. So I think that's about it for G. Anybody have any questions on how we defined that?
So it can't be f of n. The n.
It absolutely could be. So the only real crucial idea to stay away from is you don't want x to be trying to serve 2 different jobs there. But yeah, it could be f of n.
Okay.
It's just, this is a matter of convention. You know, if you have seen, I don't think Mark has talked about the fundamental theorem of calculus yet this semester, but if you've seen it before, you pretty much always see x to represent the upper limit of an integral, and you almost always see t as the variable inside the integral. So we're just kind of keeping with the things that are commonly done there, but in reality, variables and parameters can have any name you'd like.
Okay, thank you.
No problem. Anything else about G? All right, let's think about H then. So what is that number? What is that function H of n? What is that value giving us? So let's look at it starts accumulating at, where does it start accumulating? What x value?
0?
I don't think it's quite 0.
Is it the
Oh,
Sorry, what x value? I'll be more specific. So Michael says total height accumulation starting at 1. I agree with the starting at 1, but I do not believe that H is accumulating. Well, I think there's a more accurate way to say than accumulating height. What's H really accumulating?
area?
It's gonna be area, right? And what kind of area?
The rate of change?
Well,
is it the absolute area?
so absolute area, what is the other term that Mark has been using for that?
Signed.
I heard signed. Jillian says unsigned area. Kevin says true area. So a lot of different synonyms, but yeah, unsigned area is what we're looking at. So let's talk about this first. What is unsigned area? So I think it's probably easier to answer that question when you compare it to signed area. Signed area means that it can be positive or negative. It can take either sign. Unsigned area means that you can, all areas are positive. And I think, when you first learn about area or when you think about area, it doesn't make a ton of sense for it to, by default, take negative values. Which is sometimes you might hear a mark or you might see it in a written total area, which can also be a representation of unsigned area.
What do you say about unsigned area again?
Oh, I said a lot of things about it. Basically, the big difference between, actually, I'll let one of you just give me the big key difference here. The difference between signed area and unsigned area.
Signed area subtracts the area below the x-axis, whereas unsigned area is always adding either above and below.
Okay.
So the way I think of it is, so the difference between signed and unsigned area is like the difference between a person's height and like a negative height, because it doesn't make sense to say someone is negative 6 feet tall.
Right.
It has to be positive.
Right. And I think Ben, and I'm sorry, I did not catch you who was just speaking, but the big key between signed and unsigned area is one can be negative and the other one cannot be. So signed area can be positive or negative depending on where you are. Unsigned, all areas are positive when you're thinking about unsigned area. So back to this example here. Why do we know that H is giving us an unsigned area?
Because it's always positive.
It's always positive. That's true.
It's
So
not
one thing I want to,
decreasing when the rate of change goes negative.
right, and that's the big takeaway. Is so the area is still increasing even between x equals 2 and x equals 3, where the area is accumulating below the x-axis. So that's why it's unsigned area. All right, so let's do what we did before then. Let's write an integral to represent this value.
I think it'd be the same as the last time with an integral, but this time from 1 to x.
Okay, from 1 to x. All right, and then what is the integrand?
The absolute value of f of t.
Okay. We okay with that?
I like it.
Okay, I think it's good. So yes, it's going to give me an area, but if my rate of change becomes negative, I want to treat that as positive. So that's how we do that, dealing with absolute value. Let's do this one more time, except how would I represent this area without using the absolute value operator?
Could you put a negative sign next to f of t?
A negative sign next to f
I would
of t.
do it with a branch of.
Yeah, I think 2 integrals would be the easiest way.
Okay.
Just
So
make
I
the
got
second
one
negative.
vote for a negative sign out front. One vote for a splitting of this between
Branching.
2 intervals. Okay. So I think a negative sign that is going to come into play at some point here, but I'm also hearing that we need to think about 2 different integrals here. So one more thing I am going to require here is I want x to maybe take any value between 1 and 3.
you just add h of x and g of x?
Add h of x and g of x.
Because if it's unsigned from 1 to 2, or from 1 to 2, and then signed from 2 to 3. Actually, never mind. I'm just thinking about what I'm saying. Never mind.
That's a good thought though, but I think the
Right?
limits here are going to get you. Like if x is equal to 1.5, I think h would give me what you want, but I think g would give me something negative. All right, any other ideas? So I'll give you a little bit of a hint here because I hear that, yes, we want to use a branch or some kind of a piecewise function. Where are they? So let's try looking at this as two different integrals. So I want to look at this in two different integrals, but what is going to tell me, you know, which one of these things I should use? Basically, what we have to decide now is how I'm going to divide up my x-axis. So if I'm trying to find this unsigned area without using an absolute value operator, where do I have to, how do I have to divide up my x-axis, my x interval?
So we're just doing a piecewise function, right?
Yes.
So if x is less than 2, you would do the integral of h of x, and then if x is 2 greater than or equal to 2, or greater than or equal to 2, and less than or equal to 3, then you would do the integral of g of x.
Okay, so I'm hearing some good things here, but let's start out with the division. Absolutely. So if I want unsigned area, then the behavior of this function I have to think about basically in these two places. So if 1 is less than or equal to x, which is less than or equal to 2, and if 2 is less than x, which is less than or equal to 3. So those are my two divisions. So now what I want to do is, let's think about if we have an x value that's between 1 and 2. How am I going to find that unsigned area?
Would it be f of t times parentheses t minus the initial value of x?
F of t minus times t minus,
Like a for the start of the interval?
okay. Well, I know what the start of the interval is. It's going to be 1.
Okay.
So let's go with this. F of t, and I know my starting limit is going to be 1. What does my upper limit need to be?
2?
Not necessarily, because I want this to be any x. Any value between 1 and 2.
It'll just be x.
Yeah, so this x is my upper limit. Just like if I want to have a function that accumulates, and it does so in general, I need to have that upper limit, or at least one of my limits, be something variable. All right, what do we think about this top branch of this this integral here, this function? I think we have to make at least one change here.
Would we have to add another integral whether it's from x to 2?
Well, no, because let's say, for example, let's say I want to find the value of h of 1.5. If I want to find the value of h of 1.5, then all I want to find is the unsigned area between x equals 1 and x equals 1.5.
Okay.
So if that's true, I don't really need to consult the bottom half of this piecewise function. So the problem that I am seeing with the way we've defined this integral is it really doesn't have anything to do with the fact that it's a piecewise function. So in general, if we're going to integrate to find area, the first thing we have to think about is what is the rate of change of area? So what's going to give us our rate of change of area in this situation?
That would be f, right?
F of t, right? So we got that. Our rate of change is f of t. But then what do we have to multiply that f of t by? So basically you can think of f of t, that's like a single height of a rectangle that you're going to find the area of. So now I got to find that width. What's the width of that rectangle? Chat
dt?
says dt. And that's what we're looking for. So basically this integral right here, the integral from 1 to x of f of t dt, that's going to give us the area from 1 to any x as long as x is between 1 and 2. Any questions there? All right, so now let's think about this bottom one. Right, who wants to take a try at this?
Would it be the lower limit would be 2, and then the upper limit is x, and then inside is f of t times dt?
Okay, let's take a look at that.
Would it be negative integral?
Yeah.
I think it would be negative. And why would it be negative?
Because f is negative after 2.
Right. So if I'm integrating anything from 2 to x, if I just integrate f of t dt, I'm going to get a negative number. So I absolutely want to take the opposite. I want to take the negative of that value. All right, I like this so far, but I do not think it is complete yet. What else do we need to do?
Oh, we need to sum them so that it's not just doing one side or the other?
Right. So, and to kind of illustrate that, let's say I want x to be 2.5. What area is this function right here, the way it's written? What area is this function going to give me?
The area at 2.5.
Well, it's got to be area between two places, right? So from what x value to 2.5?
2 and 2.5.
Between 2 and 2.5. But I want this function to basically accumulate area starting at x equals 1. So yes, I'm going to have to add in another integral here. What would that integral look like?
Just the first integral?
It is going to look similar to the first one, but it's not going to be exactly the same.
Why? The upper limit is 2, the lower limit is 1.
The upper limit is going to be a constant 2. Can someone tell me why the upper limit of this one's going to be constant and not variable? I got a vote in the chat. Because x is greater than 2. I'm sorry, what was that?
All right, like it might not be the right way to think about it, but I feel like once you reach 2, you kind of like remove the ambiguity of the previous section of like 1 to x, so you're no longer asking find like 1 to x. It's like that set area that you've already accumulated. So now you're just taking away the negative area.
Right, and that's exactly it.
Does that make sense?
Yeah, it does make sense. I'm just going to try to, I'll put another spin on it. Basically, just to be really clear, what the function h of x that we made, what it does. This function accumulates area between x equals 1 and x equals whatever value I put into the input there. So if I am given an x value between 2 and 3, then I need to already assume, no, I'm not assuming, I know that I accumulated all the area between x equals 1 and x equals 2. So not some portion of it, all of it. So I already know that my lower limit's 1, my upper limit's 2. But since I don't know where I am between 2 and 3, I need to have this upper limit be variable. Any questions on either one of these? All right, I'm going to go ahead and stop the share. I sent out an email. I think the file is called temperature integrals or something to that effect. I'm going to go ahead and put you into breakout rooms again.